In this video, I will discuss the very important topic in chapter 7. This is section 7.1, where I will discuss the inverse function. 7.1 contains some basic prerequisites to study the inverse function. So I will talk about the one-to-one functions as well. In this video, I might not complete the inverse functions, but we will try to complete the one-to-one functions over here. So let me just draw a table for a motivation to study inverse function. Suppose that a biologist did some experiment and find out the following data. When time was 0, the population of bacteria was 100. When the time was 1, then the population was 168. Similarly, if we continue like that, for example, when the biologist find out the population at t is equal to 2 hours, then we have 259 bacteria. For 3 time for 3 we have 358, and for time 4 we have, for example, 445. So from this the biologist find out there is a relation between time t and the number of bacteria, and we call that function of t, where n is a number of bacteria, f is a function, and t is an input. Although we don't have any functions over here, but we have a data, experimental data. So this was a calculation done by the experimentalist in biology. Now just change a perspective and draw another table. Suppose we have a table 2, and instead of finding out the time first, we interchange the value of capital N and the small t. So the first column will become capital N, which is a population of bacteria, and the time t. For example, we have time t. So rather than looking at the time t0, when you give this table to someone, he or she can identify that when time was 0, there was 100 bacteria. When, for example, the time was 3 hours, then there were 358 population, 358 bacteria. Now, if you want to change a perspective like this, for example, you say that if there are 100 bacteria, but what was the time at that population? Since this was an initial time, so we can say that we had 0. Time was 0. There were 100 bacteria. When time was 0, there were 100 bacteria. Now, if a person look at this data, for example, 259, and that person wants to see the time for that population. So he or she can look at table 1 and say that the time at that uh, population, for that population, the time was 2 hours. Okay, so we can write, for example, 2 hours over here. So the table 1 says that n is a function of t, and the table 2 says that t is a function of, for example, you are doing inverse of that. First, in table 1, you were moving from t to n. Now you are moving from 100 to t. So it means that if you need to find a time t, then that problem becomes f inverse n. So the table 2 is the inverse function of f. So n becomes t becomes f inverse n. So table 2 is an example of inverse function. Although there is no function over here, but we can make a function from this data. So this is the motivation that if someone is interested in finding the range value, the value in the range is rather than in the input value, then that person needs to look at inverse functions. So to study the inverse function, one must have some background. To study inverse function, we need a knowledge of one-to-one function, one-to-one function, one-to-one functions. Every topic in mathematics needs some prerequisite. For example, if you have an apple, if you want to you want to buy an apple, the prerequisite is that you should have some money. If you want to become a successful person, for example, then you must have, for example, the hardworking guy or girl, whatever. So there are some prerequisites. Similarly, to understand the inverse function, there is a prerequisite knowledge for that. The prerequisite knowledge is the one-to-one function. One-to-one function. We must understand one-to-one function. Now, what is the definition of, you will understand why we needed one-to-one function. So we need a definition of one-to-one function. A function is a rule that assigns a value from its range to each element in its domain. So this is the definition of function. Let me just raise one-to-one function over here so you don't get confused. Since we are, to understand one-to-one function, we are defining the function over here. So this is the definition of a function. This is a simpler definition of any function. It just says that if you have, for example, data on one set and data on another set, then for each range value, for example, this is range, this is domain, then for each range value, you must have some domain. Okay. So let me just give you an example to understand the function and then move to the one-to-one function. Suppose we have f of x is equal to x square. This is our function. So if you draw a data, suppose we have a two sets and range is 1. For this range 1, we have two values. One is -1 and another one is 1. So it means that for two input values, we have one range value. So we have for two inputs, we have only one value in the range. So we say that when we put x is equal to -1, then we get 1. When we put x is equal to 1, then we get 1. The range is 1. So multiple input elements give you only one output. Now take a look at another example. F of x is equal to sine of x. Now suppose we have x is equal to pi by 3, and then we also have x is equal to 2 pi by 3. Now the value of this function, which is sinusoidal function, we have f of pi by 3 and f of 2 pi by 3. It has a same value, which is under root 3 by 2. You can check it yourself. The value for sine pi by 3 and sine 2 pi by 3 have a same value. So it means that we have input value, which is pi by 3. Then we have another input value, and there is only one output value, which is under root 3 by 2. Okay. So it means that one-to-one means it is similar to a person sitting one-to-one with another person. So this is one-to-one, example of one-to-one. Okay. If we have one person talking to maybe a group of two people, then it is not one-to-one. So it is 1-to-2 or maybe whatever that is. So one-to-one means that we should have one value, one range value for each input value. This does not define the example, this example and another, these two examples do not define the one-to-one definition. So what will be the definition of one-to-one? Definition of one-to-one. One-to-one. Suppose we have, maybe I will go to example later on, but let me just define it formally. A function with distinct values for distinct inputs is called one-to-one. Okay. So this is very much important in finding the inverse function of any function. We must have one-to-one function. And in mathematically, we can write that f of x1 will not be equal to f of x2 whenever x1 is not equal to x2. So function will be one-to-one when it defines the mathematical condition. So two ranges at two different inputs should be different. So let me just visualize it. Suppose we have x1 over here, then we have x2. These are two distinct points. For each two distinct points, we have f of x1, then we have f of x2. These two f of x1 and f of x2 are not equal, and similarly x1 and x2 are not equal. If such condition is met, then we say that the function is one-to-one function. I hope you understand the definition. Okay, let me just give you some example, or maybe I show you some uh, pictorial representation of one-to-one and not one-to-one function. Here you can see that there is a number 4. There is a function, for example, and this is set, and this is another set. Okay, this is one set, A set, this is set B. For each value in set A corresponds to one value in B, and same is the case with another values. For 3 it reaches to 7, for 2 it is 4, for 1 it is 2. So we can write this as, for example, for f of 4 the answer is 10, for f of 3 the answer is 7, for f of 2 the answer is 4, for f of 1 the answer is 2. So this function is clearly one-to-one function. So this function is one-to-one function. F is one-to-one function, one-to-one. So that is a desirable property over here. Here, for the second function, which is g, let me just find out the value of g for each input. When g is 4, we get the answer 10. When g is 3, the answer is 4. When g is 2, the answer is 4 again. So it means that for two distinct inputs, 3 is not equal to 2, we get one value which has same range. So it means that g is not one-to-one function. G is not one-to-one function. So this is the definition of one-to-one. Let me just go to example so we can understand the concept clearly. Suppose we have f of x is equal to x under root. Now you can see that the value of f of x1 under root, and the value at x2 under root. These two values, whenever we should write that whenever x1 is not equal to x2, x1 under root and x2 under root will not be equal to each other, So you can see that we have one-to-one function over here. If we draw that function, we will see that it has actually one-to-one definition satisfied. Suppose we have this function x under root. This is y is equal to x under root. For each input value. For example, this is input value x1, it has f of x1, and similarly for each at x2 we have f of x2. Okay, so you can see that uh, for each input, if there is one value over here, we can draw a line like this. For another point, we can also draw a line like this. So we can draw two lines which are horizontal line, and this horizontal line passes through only one point. And I will connect this horizontal line with the definition of one to one. Okay. Now let's graphically look at another example. Suppose we have a graph of x cube. For x cube, there is two branches. For example, this is one branch. This is one function, complete function. Maybe I draw this in one color. This is the graph of x cube. Here you can also see that for each x1, any value x1, we have f of x1. And wherever you can take that value, this is x1, for example, you have a unique value on the curve. If this is x2, for example, we have a unique value of f of x2. If we have x3, so we have a unique value of f of x3. So it means that if you draw a horizontal line, we drew a horizontal line over here. Now we draw a horizontal line over here as well. You can draw as many horizontal lines as possible. For example, these are the horizontal line. So this is one-to-one function. This x under root is one-to-one function to 1. And this y is equal to x cube is also one-to-one function. And the horizontal line, you can see that it only passes through one point. Let me just take a look at another example where the function is not one-to-one. Graphically, we can see an example of x square. X square, this is y is equal to x square. This x square, if you, for example, take a look at the value of -1 and 1, for example, then the value is 1, the range is 1, and similarly the value of the function is also 1. So these two values, for these two values, you have only one range value. This range value should look similar, so I should raise it first. I should draw it properly like this. 1. Okay. So we have the same range value for two different inputs. So it does not satisfy the definition of one-to-one. If you draw a horizontal line from anywhere on this graph, you can see that the horizontal line passes through two function values. If I draw it permanently like this, for example, this is the horizontal line, you can see that it passes through 2 points. So it means the graph which has a horizontal line passes through 2 points, then that uh, function is not one-to-one. Here you can see that it was passing through, the horizontal line was passing through only 1 point. Similar is the case with x cube. But for x square, we have horizontal line passes through 2 points. So it means that if you want to identify either a function has one-to-one or it is not one-to-one, you can test it by horizontal line test. So this is called horizontal line test. So horizontal line test for one to one function. So what is the definition? The definition is a function, a function y is equal to f of x is one to one, is one to one if and only if and only if its graph intersect each horizontal line, each horizontal line at most once. So this is the horizontal line test. If you want to check either a function is one to one, you must it should pass the horizontal line test. So this was all about one-to-one function. In the next video, I will talk about the inverse functions. Thank you for watching.